In this screencast, we're going to create a right triangle and isosceles triangle using the instructions in the lesson. So let's go ahead and we'll do the right triangle first. We'll use the text tool and just click in the window here, and we'll just label this right triangle. And actually, let me just show you some symbols in here. We'll call this right triangle ABC, or CAB we'll call it. And if you go to the symbols, you can have some tools here that you can pick up, and there's a nice little triangle symbol, and then you can just call it CAB, cab. We'll call this one cab. The right angle will be angle A in this problem. And then there we go. So that'll be, again, you can change the text, you can change the size, so forth, if you want to make it fancy. We'll leave it the way it is for now. All right, our first step in creating the right triangle would just be to create either a random line segment or 2 points. I'll go with the line segment for this, and it should automatically put in the AB, and there it is. About that length is fine. Okay, the next step is not freehand. The next step is we actually have to create a perpendicular line. That's a definition of a right triangle. It has a right angle in it. So to do that, we will use the perpendicular tool. And that's up here, perpendicular tool. Highlight either A or B. I want to make A the right angle, so I'll highlight A and then highlight the line segment itself. And that'll create a perpendicular line. Now to create the third point of the triangle, using the point tool. And you can put it anywhere you want as long as it's sitting on the perpendicular line. I'll leave it right about here. That looks good to me. And that creates the perpendicular line. We just need to make a segment now to finish up the triangle. So to clean things up, I am going to hide that perpendicular line. In fact, here it is in the algebra window. There's the perpendicular line. Again, a reminder, if you want to change that to y equals mx plus b, there you go. And then that'll give you the slope and the y-intercept if you're interested. Okay, let's go ahead and hide that. We can hide that just by clicking on this bubble here, and then that'll make it disappear. Makes our construction very clean, because now we can go ahead and use the line segment tool to connect the points, and there is our right triangle. The only thing left to do is to confirm it's a right triangle by using the angle measurement tool. So we'll go ahead and measure each angle. Angle B, angle A. I have my rounding set to 0 for this activity. Doesn't really matter. And there we go. And so we've created the right triangle. I'll just slide these a little bit lower here so you can see them. I don't really need the 90 because the box tells us it is a right triangle, right angle. And print that outside. Okay, and then you can just go ahead and move these around. I do want to point out to you that if this is a 90-degree angle and the triangle adds up to 180 degrees, the other two must add up to 90 degrees. Those are called complementary angles. Two angles that add up to 90 degrees are called complementary. So if you have a right triangle, one of them is already 90, that's given. The other two have to add up to 90 as well, because the whole thing's got to add up to 180. And then go ahead and slide around point B. Sliding around point B or point A, you can go ahead and change the values of those angles. You can orient it any way you want, and then that's how you're going to get your triangle. If you want to make it look nice, you actually want to color the inside of it. You can use a polygon tool and just highlight the 3 points. Just remember to click on the first point as well as the last point, and that'll create the interior. Then you go ahead and shade it any way you like, and that would be triangle, right triangle CAB. Or right triangle BAC would also be correct, as long as that middle point, that right angle, is the middle letter in your description. You want to make sure the right triangle is in the middle there. Okay, so let's move on now to the second part. The second part was creating an isosceles triangle. Now, to create an isosceles triangle, we actually need circles for that, because we need to build the isosceles triangle off of the radius. So let me go ahead and slide this up a little higher, and let's give this a text here. We'll call this one isosceles triangle. And we're going to use the same letters here, so we can actually use the same symbol, triangle. We'll call this one triangle ABC, just to make it a little different from the right triangle. ABC. And so there we go, and then again you can make that bigger, smaller, whatever you like. Oops, I'll go the other way with it. Okay, so now let's go ahead and do that. So we're going to create 2 points, and those 2 points are going to represent the radius of a circle. So let's go ahead and just put down 2 random points. Then go to the circle tool and circle with center and point. And so we'll use point D as the center, and point E will be sitting on the circumference. Okay, so pretty much we've got a basic circle. We'll use the line segment tool to make the radius of the circle. And this one is going to be really simple. Unlike the equilateral triangle that we made, we needed a second circle that started at E and went to D, if you recall that lesson, because that gives us 2 overlapping circles. We found the intersection of those 2 circles to make the equilateral triangle. This triangle is a lot simpler. It's just isosceles. 2 sides are the same and the base angles are the same. So all we really need for the isosceles triangle is to create a random point on the circumference. Just put it anywhere you like. This looks good to me. And then use the line segment tool, and we will connect the center to that point F here. That gives me 2 sides that are identical. I know they're identical because they're 2 radii of the same circle. And so that's how I know these 2 segments are the same. And we can actually mark them the same. So here's another tool for you. You can mark them the same by going to, if I right click on it on top of the line segment, object properties, it's under decoration. So if you go to decoration, you have some choices here. You can mark them with these congruent marks. So I'll use a double slash to mark these. So close, that'll mark this one, and then I want this other one to be the same mark. So right click, object properties, decoration is where you'll find it. Okay, go ahead and create that third part of the triangle. There we go. Line segment connecting F and E. That'll be the base of our triangle. And we're pretty much done with the circle at this point. So let's go ahead and highlight the circle in the algebra window and just click on that bubble, and that'll hide the circle. Now this third side of the triangle is not the same as the other 2. If you drag E or F, you can clearly see that that is not, it doesn't match, which is good because we didn't want an equilateral triangle in this case. We want isosceles, so we want a more general situation. So let's go ahead and mark that bottom point the same way we did the other point, the other line segments, by right-clicking, object properties, decoration. Now we don't want to use the double hash marks because the double hash marks will tell us that it matches the other 2. So we'll use 3 hash marks or 1 hash mark. I'll use 1 in this example. And then go ahead and close it. And now just by looking at the picture, you're telling the reader that yes, you have 2 sides that are the same, and you have 1 side that's different from the other 2 because you have 2 hash marks versus 1 hash mark. Okay, now the properties of an isosceles triangle is that the base angles right here, these angle F and angle E, are also congruent. They're the same size. So let's prove that by using the angle tool. So we'll get the angle tool, measure the angles. So that one's 70, this one better be 70, sure enough. And that top one, I don't know what the top, if these 2 add up to 170, then the top one must be 40 because the total adds up to 180. And so there we go. We can just drag those across like that. And we have created our angle marks. Now we have the angle measurement, so we can clearly see that 70 and 70 match and 40 would be different. But you could do the same thing. You can actually, if you click on the angle and right click on the angle, go to object properties, you have that decoration tool available to you. And so here you can see where you can change either, you can do double arcs, single arcs, you can use those hash marks like we did earlier. So let me go ahead and do the double arcs. So this angle right here, that angle matches this angle, so I will use the same double mark I used on the first one. And now that tells me that these 2 are the same because they have double arcs on them. This one only has a single arc because that tells the reader. So if you didn't have any measurements here, if these measurements were hidden to you, in fact, let me do that right now. If I right click on top of the 40 and just hide that label, same thing with the 70s, hide those labels. Just looking at the picture, I know that this is an isosceles triangle because these 2 base angles are the same. And that third angle is different because that only has 1 arc versus 2 arcs. And go ahead and drag it around, and you can see that if you go the opposite way, GeoGebra actually measures the outside angle. So just stick to the right side on this particular example. and you can see that that is an isosceles triangle. So there you go. You created an equilateral triangle earlier in the course. You just created a right triangle here. This first triangle here that we made is a right triangle. And you can drag it around just by changing the A and the B. Or our last example was isosceles triangle, and again, same situation. You can move D just to move where it is on the screen, and then you can use points F and E. And one last thing for this video, just to wrap it up here. If you go to the algebra window, you notice that what we discussed before, you have free points and dependent points, so the dependent points rely on the free points. But organization-wise, I'm not crazy about the organization free points, dependent points. I'd much prefer organizing it by category. So if you drop down this menu here for the algebra window, a little circle with a little line segment on it, click on that toolbar, and what that does, that organizes your information based on angles. Here's your circle. We only have one circle here. It's hidden. If you want to see it, just click on that. The line, we have one line, how many points we've used, and how many segments. I find this organization much more useful than the free objects versus dependent objects, and I encourage you to use it as well.